Thank you for coming to my presentation, Art as a Communication Interface for Watershed System Resiliency. My name is Adrienne Mason. I'm a master's candidate at the University of Waterloo, Canada, under the supervision of Dr. Stephen Murphy. Art has shown increasing promise as a method for communicating the science and attendant need of watershed restoration work to both practitioners and the public. My research explores whether an exhibit of eco-art can convey the message that restoring connectivity and capacity can increase watershed system resiliency. Literature review showed support for the message that restoring the potential for water storage capacity on the landscape and lateral hydrological connectivity could increase watershed system resiliency. And even influence precipitation patterns in small water cycles. The emerging discipline of socio-hydrology endeavors to link water management regimes with both the small and large water cycles that make up the global water balance, and further proposes that changing our water management regimes towards restoration could help to mitigate aspects of the climate crisis. I explored the message that restored connectivity and capacity could increase watershed system resiliency through a case study in the South Pine River in partnership with the Healthy Lake Huron Working Group and the Pine River Watershed Initiative Network. Large nearshore algae blooms spurred a group of concerned citizens to form the Pine River Watershed Initiative Network that focused on resolving this non-point source nutrient pollution problem. Habitat connectivity was restored in the Pine River watershed to combat this nutrient pollution problem through reforesting riparian corridors, as recommended in an Ontario Nature report, which proposed linkages between remnant forest patches in this region of southeast Lake Huron. Over 260,000 tree seedlings were planted within the Pine River watershed. However, issues of nutrient pollution feeding the nearshore algae blooms persisted. Over 90% of the Pine River watershed is systematically tile drained, meaning that surface water is pulled through a network of buried pipes that bypass the riparian forests and dump into adjacent waterways. This is done to enhance agricultural productivity. I worked with the group Healthy Lake Huron Working Group and the Pine River Watershed Initiative Network to develop a project in the South Pine River headwaters, circled in blue, to hone and enhance watershed restoration techniques given these current land use parameters. The flashy nature of the Pine River watershed's hydrograph belies the water management regime in this region. Surface water shunted from the agricultural fields not only has increased the kinetic rate of flow in the South Pine River watershed, it also carries with it up to 260 metric tons of topsoil during a storm event. 8 water and sediment control basins, or WASCOBs, were installed in the South Pine River headwaters to restore water storage capacity on the landscape and to increase watershed system resiliency. These WASCOBs and sediment control wetlands were created to mimic the function of historic swamp forests that would slow and hold water on the landscape, while these WASCOBs allow agricultural land use to continue in the Pine River watershed by holding water back for a period of 24 hours and allowing sediment to drop out of the water column onto the fields and the crops to survive. Field-scale studies conducted by Asapel Bayfield Conservation Authority as part of the Healthy Lake Huron Working Group showed that the force and peak rate of runoff leaving the Wascog areas was significantly reduced following storm events. The series of 8 wascobs in the South Pine River headwaters restored water storage capacity on the landscape and lateral hydrological connectivity, also corresponded with a reduction in the total suspended sediment loads with a p-value of 0.05 that was suggested to be a measure of resiliency, indicative of conserving topsoil in this agricultural system while reducing nutrient and sediment pollution in the near shore. These watershed-scale observations also aligned with tenets of Bernoulli's law in hydrology, which explains why water moves at the microscale. In a system where pressure is uniform, such as the perched Pine River watershed, potential energy, which corresponds with storing water on the landscape, is increased when kinetic energy is decreased, which corresponds with the reduction in peak stormwater flow in the waterways. The macro-scale environmental problem that I chose to situate this research within is that climate change will increase the intensity of the Earth's hydrological cycle in the next 100 years. This will cause more extreme precipitation events and affect water quality and quantity in local watershed systems around the globe. This will exacerbate current environmental problems in these local watersheds. The trajectory of humans' carbon footprint is dire. The rate at which we are causing climate change is likely to lead to catastrophic consequences. At both global and local levels, watershed systems will become destabilized if we continue on this path. Our collective human behavior has become geological in scale, in that it is not dissimilar to that of the KT asteroid that impacted Earth and effectively ended the era of the dinosaurs. Many experts agree that if we're not careful, we could tip out of the Anthropocene epoch into a new Earth system state without the predictive and supportive conditions on which humanity has relied. The scale and complexity of this macro-scale environmental problem can become a barrier to communicating watershed restoration messages to a broad audience, in part because it can trigger eco-anxiety or environmental dysphoria, and also that discipline-specific language can impede understanding. Ecological art can be used as a tool to bypass these communication barriers and allow people to engage with difficult environmental problems in novel ways. A specific research gap for eco-art being needed as a tool for communicating the importance of resilience in complex watershed systems has been identified. In particular, water cycle diagrams are needed that incorporate connections between people and water across spatial and temporal planes within the context of known global hydrology. Artistic symbolism has been used for millennia to communicate complex messages, such as the Ouroboros, which is the image of a snake eating its own tail, either in a circle or lemniscate shape. This simultaneously represents both renewal and self-destruction. This trope can be linked with modern systems theory in the form of Holling's loop by the similarities in the form. The Holling's loop describes a system that is subject to 4 phases: growth, conservation, chaos, and reorganization. The x-axis of this loop is on a scale of connectivity, and the y-axis of this loop is on a scale of potential energy. A resilient system is able to move through these 4 phases, even in the presence of environmental stressors. A human heart is an example of a resilient system that has 4 distinct phases: the left and right ventricles and the left and right atrium. A healthy heart is able to respond to stressors by changing its rate but maintaining its function. In this way, watersheds could be viewed as functional systems, ones that have dynamic equilibrium states that support socio-ecological communities. We want to maintain these beneficial functional states, and it is proposed we can do this by restoring connectivity and capacity. Holling's hydrology loops were created in an attempt to incorporate watershed restoration messaging with Holling's loop, showing a resilient and adaptive system, and Bernoulli's equation on how water moves in response to changing the potential energy component of a system. This was done by inserting water into a closed lemonade-skate shape. The oscillation of the Holling's hydrology loops is meant to portray a watershed system functioning in a resilient and dynamic equilibrium state. I constructed several kinetic sculptures, one that represent the small water cycle, another to represent the Earth system state water balance, and house them within a watershed as part of an eco-art exhibit that was shown 8 times to varied audiences to see if it helped convey the message that human behavior now affects the functioning of almost every watershed on Earth. If people made informed decisions to act in a restorative way towards local watersheds by increasing capacity and connectivity, we may be able to influence hydrological feedback loops and small water cycles, which could help to prevent tipping the Earth system state water balance into an unfavorable regime.